In this video, we are going to compare between combination with replacement and combination without replacement. So here we have the formula of combination without replacement, and here we have the formula of combination with replacement. So let us start the comparison between combination without replacement of n different objects taken R at a time and combination with replacement of n different objects taken R at a time. The first condition is both objects are defined over sets. So in both cases, objects are defined over a set, and in both cases, sequences need not be ordered. And the third comparison is the size of the sequence. So here sampling could be 1, 2, 3 up to n in combination without replacement. However, in combination with replacement, sampling size could start from 1 until infinity. So that means that in the case of combination without replacement, the maximum size of the generated sequence is n, while in the case of combination with replacement, the sequence size can be unlimited. So this formula can be applied for the case of no replacement, and this formula can be applied for the case of replacement. So the main difference between them is that in this case we apply it without replacement, and in this case we apply this formula with replacement. So what does that mean? If we have the case of no replacement, it means that objects do not repeat in any generated sequence. So if we have a sequence such as B, A, C, E, D, we notice that no letter repeat more than once. However, in the case of combination with replacement, objects do repeat in portion of the generated sequences. So we may have a sequence such as BB, C, and DD, and we notice that B is repeated twice and D is repeated also twice. So in such case, in the case of combination with replacement, we find that portion of the generated sequences has repeated objects and the other portions do not have repeated objects. So we are going to have both kinds of sequences, sequences where objects repeat and sequences where objects do not repeat more than once. We also have to remember the definition that n is the number of objects in the set and R is the size of generated sequences, or the number of sampled objects. As we have seen, combination with replacements allows repetition of letters in the generated sequence. So combination with replacement is always going to be divided into sequences with no repetitive objects and sequences with repetitive objects. So in such case, the number of combination with replacement is equal to the number of sequences with no repetitive object plus the number of sequences with at least 2 repetitive objects. However, the number of sequences with no repetitive objects is equal to combination without replacement. So this portion here is always combination without replacement, and now we have a relation between combination with and combination without. So combination with is equal to combination without plus the number of non-ordered sequences with at least 2 repetitive objects. Or we can write that in a different way. combination with replacement minus combination without replacement is equal to the number of sequences with at least 2 repetitive objects. Thank you for watching and have a good day.